Hey, I'm FTFE from the channel that ties stupidity to the train tracks of knowledge, and I'm here for this historic occasion as MC Toon and I learn about the demise of one of the fundamental forces of the universe, as far as we understand it. It is the time to learn why gravity isn't what we've been taught. I am beyond excited to be part of this discussion between MC Toon and his competitor today. MC Toon, thank you for letting me be here.
Oh, I'm glad to have you. This is exciting, historic to have this presentation. It's gonna be amazing. So I'd like to introduce Doug DeArros, who's going to be presenting his model of life, the universe, and everything.
Thank you, Craig, or Mr. Michael, Mr. Toon. Sorry,
whatever.
You got mine wrong. I'll have to return the favor right off the bat. And Mr. Craig, it's so nice to see you again.
Lovely, thank you. Looking forward to this. Very excited. Gravity's a longtime friend of mine, so you know.
So we've got a very exciting announcement today. Two unique experiment-based discoveries that seem independent of each other, but actually support the same idea. I'm going to save the punchline to a little bit through my intro, but my goal today is to introduce those two and then start to lean into the model that will do a pretty accurate job of describing them. They're going to raise both of your eyebrows. One of them is going to contradict just the most basic assumptions, such as light traveling in straight lines, the Earth being a sphere, us being in an infinite amount of space. That's a fun one. But the more interesting one is very clean cut and straightforward. I like your literature there. He's reading a physics book, and I'm using mine to prop up my laptop. So two completely different individuals on the live podcast at this point. But anyways, so I've got my textbook handy. I've got a digital version as well, ready to reference on screen. I've got a few YouTube videos and a bunch of deductions based on one single assumption. Now, I'm not going to be able to prove that assumption directly, but I can indirectly prove that this assumption will usually hold true. I think I might have to dive pretty deep to find out how it won't work, because I've spent the last 10 years trying to disprove this. But I finally gave in, and that's when I decided to drop out and write the book. So it's available on Amazon. I'll link it later. But for now, let's get into the discussion. So do I have any questions or comments so far, or am I free to continue?
Personally, I'm just excited.
I'm good. I am too. Trust me, I haven't slept much in the last few days. So if I stumble, just hang with me. I'm working on it.
Sleep is for the weak.
All righty. So shall we begin?
Yes.
Let's get into it. So I'm going to share my screen so you guys can see everything I'm doing. If I forget to, there's a TV behind me, obviously, that you can just squint your eyes at. But let me go over to the Zoom call, and if I can find it, hit the share video button, if I can find it. There we go. And share the whole screen. I'm not afraid of y'all. I'm not afraid of showing anything. Anyways, so what you see here is a list of statements that Mr. MC Toon and I, and perhaps Craig, if you want to share the file with him there, Michael, then we're going to list. On the left is I, and on the right is my competitor, and we're going to list things that we agree or disagree on. These are true or false statements. They are not arguments. So it's a single statement, and there should be binary in debate. But if we disagree on something, we're going to focus on it until we can come to a conclusion. Anyways, first off, this is my website. It has the book available to read for free. There's no ads. I think it still has a sign-up requirement, but I'm planning on removing that. We're going to use this to reference. Let me just go ahead and load these so I can scroll efficiently. And without any further ado, I think I'm ready. Let's see. There's the index. Let's begin. All right. Let's see. Where was the beginning? Just a moment. I said I was sleepless. So we're going to start with the experiment. Okay, so in the early 1900s, late 1800s, the interferometer was beginning to become a widely used experiment. This is a device that sends a laser beam down a corridor where it's intercepted by a beam splitter. Half the beam will go straight through, and the other half will take a 90-degree angle. Those beams then are intercepted by perfectly flush mirrors. They come back to the beam splitter, and they come out the other side. That's what we see here. If I want to back this up a little bit, traditionally, they were testing the motion of the planet through space. They're trying to find out what direction it was going in, at least. And by using the laws of waves, not necessarily light, but the laws of waves, they assumed that a Doppler effect would show up in the direction that we were traveling. So they tested all directions. And famously, it said that the Earth was, directly interpreted standing still. So this made no sense. And that's when Einstein stepped up to give us relativity, or special relativity, saying that while we move through space, our inertial frame of reference moves through space. And that is where the speed of light remains constant. So it's kind of like the speed of light is moving with you. And there's a couple interesting deductions you can make from that, such as length contractions and time dilations. We know that astronauts experience slightly shorter seconds because of their speed. But I disagree. I don't think it's because of speed. I think it's because of something else. But anyways, so the discovery that was made by the man who posted this video, who is Dr. Martin von Grusnick, he was not aware that it's a groundbreaking discovery. But what he did was he turned it vertical and then rotated it sideways. Let me speed this up. It's already at double. This is a very slow moving object. So what he saw when he changed the altitude of each path, ignore the adjustments he's making right now, he's just calibrating the machine. When he rotates it up and down, the changing of the altitude caused the interferometer to interfere with each other. And you see here the interference pattern moving left and right as the interferometer rotates up and down. And he was able to pinpoint the moment at which it was at its lowest, as you see here, or the highest. I actually have a hard time telling which up and down in this video, but he'll diagram that out in the end of this video. But without waiting on that too much, let's move on. Escape. Oh, I thought I had a video prepared. Let's see. That was supposed to be. So I made my own interferometer out of Legos. This should be muted. It is. And I recreated this experiment to see for myself. As you can see here, it's supposed to be rotating side to side. I know it looks ridiculous, but it has a $150 little glass cube in there that is supposed to split this beam. I took the mirrors off my old truck, and I just hot glued a bunch of Legos together so that it was rigid, and they couldn't say that it was the flexing of the experiment causing this to happen. So as I wait for this version of me to show what it looks like once it's working. There we go. Anyways, went too far. So we see here that the same thing happens. As I tilt the side that's closest to the camera up, the beams, the vertical dark and light beams shift left and right depending on the altitude. So that is groundbreaking. Now I know we can account that for the difference in density and mediums, which is why I need to expand my research into going to that the giant vacuum chamber that NASA has. I'd love to do that, or just make one myself. But now on to the second experiment, the seemingly unrelated one. This was actually supposed to be the second experiment. I just kind of jumped around. But let's go into the book. That's why it was the first tab, slightly out of order, but I can save it. We are looking for why I traveled out to the salt flats of Utah. And the reason is because of this straight line. This, if you don't know if you could see, let me try to increase the definition here just by clicking on this. There's a little dude here. I think he looks like William Penn. He's looking out onto the horizon, and we can see this white dotted line at the top is tracing out the beam of light that should be his horizon. Then if we use the trigonometry of the Earth being a sphere and the horizon being part of the hypotenuse, subtracting the radius would give us the predicted altitude of that horizon. Now I have that data with me. At least I downloaded it, but I did not put it in order, so I'll omit that for now. But if I were able to, oh wait, it's over here. So we've got these numbers. We'll come back to them later, but different tab. Sorry. This is my first Zoom presentation. You'll have to bear with me momentarily. I'm sorry. I'm really having a fun time here. Oh yeah, the book, sorry. Okay, so the bottom line is a curve that makes no sense if it were to represent the trajectory of a beam of light. What I'm predicting is that based off of this one piece of data that I have, in lieu of the hundreds of pieces of data that I set out to get but failed to because I just simply didn't have the equipment to go on with the salt flats when it was soft. There is a 75% discrepancy at 50 miles of Earth's surface. What I mean is the math here tells us that you should be able to see 0% of these buildings based off of that math, but we can see 75% of it. Now, I know you're thinking it's due to superior mirage, or it's due to just regular mirage. I'm not sure what the difference is because I know it doesn't work. Mirages are currently explained based off of atmospheric changes, the difference in density in different temperatures of air. So it makes sense that the beam of light would curve towards the normal when going into more dense mediums. However, this is a perfect translation, and it is very, very predictable. It has nothing to do with the temperature or the weather. It is a fundamental curve that light is subject to, and I will expand on that after I let my friend here interject because it seems like he wants to say something.
No, I'm good.
Okay. Well then, let me see
Sorry,
where I'm at.
I'll mute myself. I'll keep my noises.
No. I like the time off the monologue. It's relaxing. So anyways, what I have here are two colors of dotted lines, which if we take the Earth's surface as a sphere and we flatten it out just for measurement purposes, then we can predict the altitude of the curve up to 25% of the way around the Earth, given about 6,250 miles. That is because we know that a beam of light shot horizontally will eventually be perpendicular to someone 25% of the way around the Earth looking straight up. Oh, sorry, I didn't, let me push these out of the way. Anyways, refocusing. So with the few data points that I have collected based off the testimonies of pilots and others with photographs and the geographical locations attached to those photographs, I have predicted that this curve, the blue one, will be the actual results that we experience. Now, I need to go to salt flats to confirm this, but that will only give me that strange upward curve that I showed you in this book. It looks like gravity is sucking light towards the Earth, but as the light approaches that 25% around the world asymptote, if that's how you pronounce it, it appears to straighten back out in its original trajectory, just a few thousand miles off. So we need to go to an extreme case in order to show that that is the nature of light. And in order to do that, we will need to send a very large, very bright balloon up from the northeastern coast of the United States and have observers located all along the eastern coast of both North and South America. A smaller scale version would be put something along the lines of Tampa Bay and just have everybody lined up along the Gulf of Mexico. But that is a possible verification that we could use to show that light curves down and then back up. So, but what model explains these experimental results? And I'm going to get into that right now. So my entire theory is pinned on this assumption that there is a spring of ether between the electron and the proton, which separates what I sometimes refer to as the anti-neutron, as you see in this diagram here. Is that too far zoomed in? Let me
That's a little, yeah.
Let me back that up just a bit. I'll get the theater mode going on here. That should work, shouldn't it? Let's give it a second. So how does it look? Better?
Yeah, that's
Good.
fine.
All right, so this diagram is my entire theory in a nutshell. If we assume that protons and electrons are attracted to each other, it can be described, and here's one of my first statements. The attraction between protons and electrons can be described using Coulomb's law. I say that that is true. That is debatable, so I'm going to say that's an assumption, but I'm going to say that I believe it is true. And we can debate that for probably the next 12 months and have a lot of fun with it. But getting back to the presentation at hand, if this assumption were true, which we'll try to verify later, then the nature of the atom would be much like this. It's consider us a tiny universe with only 4 sets of particle. That is 4 springs of ether acting on 4 antineutrons, separating them into 4 sets of siblings, I call them. The siblings being those attached. Now we know that the protons are attracted to the electrons, but this spring prevents these two from being attracted to each other directly. So keeping that in mind, there are probably about 3 major parts to explaining gravity here, but we're going to focus, we're going to neglect the...
Just to be clear, we have, what are the yellow things?
The yellow things are springs of ether. They're really poorly drawn out here, so I should probably go back to the book.
And what were the red things?
Protons.
And
so
then
you had a red and a yellow dot there connected by a yellow spring. The red were the protons, the yellow dots were the electrons, and the spring was the aether spring connecting the two.
Yes.
Right?
And here's a much better image that shows that.
Wow.
Okay.
So
the electron and the proton are connected by the aether spring?
Yes, but only a single unique pair. Not all electrons are connected to all protons. So there are a seemingly infinite number of these springs that create a sea of these ether. And I'll let you in on a hint. They all converge somewhere, but they're very orderly, and it causes the atom to be inside out if we're taking this one step further. So we are going to start with a tiny Big Bang, and then we're going to see how it would play out. So,
and just to also be clear, in the middle are these, what color are those things in the middle of the 4?
Gray.
Gray. Those are electrons.
Neutrons. They have no charge.
Where's the electron? Where's the electrons in
the
this?
yellow dots are the electrons.
These are the electrons.
On the outside, okay.
Right. I can go to a better image if you want a good visual.
Ben D says his whole screen is not showing force. No, it is. It is. I'm just he's just kind of I'll adjust a little more, but he's showing, like, zooming in sometimes a little too much and stuff. So
yeah, I'm gonna try to make this screen a little smaller so it doesn't have that issue in the future.
Okay.
So I'll try to center it right here. That should be that. So anyways, let's get back to this video. Or actually, I have a small slide-by-slide presentation that we can jump into to focus on this more intricately. So we have these 4 bits of energy that become the ether, and they separate the 4 anti-neutrons, the black holes that you see here, into these pairs, these 2 imaginary particles. Imagine it's like nothingness of the universe before the Big Bang is represented by a smooth beach made out of sand. If we were to dig a hole, we would create a pile. That's like the matter and the antimatter, or the neutron and the antineutron. Now, if you wanted to dig up the whole planet, you would eventually cancel out the old holes with the new piles, and that's what the state of the universe was before the Big Bang. It was static, constantly matter and antimatter canceling each other out. That's just where I'm going with this artistically. But if you were to somehow fill in that hole with an imaginary substance by creating an imaginary anti-substance and separating the two, then that's like putting imaginary sand in the hole and having an imaginary anti-sand somewhere else. And that is basically the fundamental idea of 1 and -1 being the neutron and the antineutron, and the 2 imaginary numbers, that is the square root of -1, being the imaginary particles. So it's very parallel to the mathematical logic of the imaginary number being the imaginary particles, but that allows the universe to exist. So from nothing plus energy, you can essentially get this all 3 forms of matter existing at once, plus this spring of energy, allowing it all to exist that way. So I know you're eager to get into the testable vector formulas of gravity. So without further ado, again, I use that word, these are the dotted lines that you're interested in. The dotted lines are repulsive forces between protons and protons, and between electrons and electrons. The arrows that you see between, say, these 2 guys are the ether, and the solid lines are the attraction forces. So
so to be clear, you have replaced electromagnetism with ether.
Well, not necessarily. Ether
to
is an
have
additional force that was previously overlooked in a way, and I'm trying to introduce it, and
yeah, but
by figuring out the rest of the forces,
yeah,
I can deduce what the ether actually causes.
Yeah, I'm trying to get some clarification here because due to Coulomb's law, you know, electrons and protons are attracted to each other outside of whatever additional thing you might be presenting, right? Am I understanding that right?
Right. So what I'm saying is I'm using Coulomb's law as like a temporary placeholder for this theory while it's in development. But I'm sure that we can experimentally verify how by removing the centrifugal forces and the attraction force, we can figure out how much left is there regarding the spring's contribution. But the reason that I can say that gravity often acts like charge, like Coulomb's law here being this function and gravity being a very similar looking function, it is because that is part of the net force that we call gravity, the outward acceleration of 9.8 meters per second. So I'm suggesting overall that there are about 3 major parts in one tiny, almost negligible part, which is the spring. The spring just fundamentally causes the atom to be inside out, which the video should be explaining and not me rambling on about. So let me try to get back to this without trying to confuse the audience and my competitors, because I gotta say everything I need before I give you the floor. So let me try to zoom back in. That should work, and I'll hit play. Oop, too far forward. I gave away some information. All right, so that's what the Big Bang should look like. I'll play it one more time. It is essentially a Big Bang followed by a big implosion. And then because these electrons are attracted to all the protons, essentially, then they want to be in the average location of all the protons, you know, or conceptually speaking. So that's why I believe that they would reside in the middle. And these protons are masses on a spring going around in circles that try to drag the electron away from the center. But because of that spring, the electron remains, holds the proton in close with a radius, preventing it from flying off into the abyss. And that is why I believe the atom is inside out. So that's part 1. Now part 2.
All right. So the electrons are in the middle.
Yes.
And what holds them together?
The ether is responsible for the electrons being in the middle, and I'm eager to get some.
So you've replaced electroweak holding protons together with ether holding electrons together.
Right. And making them be inside instead of on the outside on a valence shell. They're inside of the protons and neutrons because of the force created by the spring.
Right. So the spring acts more like a leash and exerts only a negligible amount of force, because remember, it just prevents the attraction between that particular electron and that particular proton, but it acts more like a limiter on how far away the proton can get from the center. But I'm going to go ahead and say that the weak forces can, you know, I'm not a college graduate with a bachelor's degree. Like, I'm very close to it, but I dropped out several times and I just decided to do it this way. But I believe that the weak forces that hold atoms together could be described by the entanglement of these springs. And we can save that for a later debate. I would consider it a pseudoscience, more like a speculation on my part, because I can take this thing so far, but honestly, I need a bit of an army of grad students to get the next book solid.
Hey, Toon, I do see PhD Tony in the chat, and I'm slightly concerned for him.
Yeah, he is probably gonna have an aneurysm. So PhD Tony, be careful. Maybe pause it, breathe deep.
I know.
Sorry. All right.
But all I'm saying is I'm making claims here. I took the concept of this assumption and now I'm making claims along the way. And at some point in the next 10, 15 minutes, it's going to make a lot of sense. Oh, because can
I just ask, that big assumption that you're making, what made you come to that assumption? Was there an observation or?
Yes. And this is going to sound ridiculous, but I'm just going to read the back of this book here. It says, in 2nd and 3rd grade, I spent the whole first day of class skimming through the diagrams on the new textbooks. I came across this one of the eyeball and how the lens flips the image that you see upside down. So I always just kind of thought the ground and the ceiling were actually flipped. So I entertained that idea, and then eventually I came to this this bizarre conclusion, but I couldn't disprove it. So I had to find an assumption that supported that conclusion. So I really did this backwards, but I've always had this answer in my head, and I've just kind of had to dig it out. And after learning about the interferometer and the laws of light in modern physics, I decided that this is all the information I need. I'm ready to go. So that's where we're here, but we're all on the bridge. It's not going to make sense until I get closer to the end of this book.
Let's keep going then.
All right. So if we can assume that conceptually this is what follows, then we can consider a universe with more atoms, and we'll see that those with the lowest proton to mass ratio, as you can see, this guy is about 33% protons, 50 and 100. Then the heavier elements, in another sense, are going to be centrifuged out towards the edge. So we'll find a lot of hydrogen floating around the center, but we'll find the heaviest, most nuclear radioactive ones as the shell. And I say shell because once you have enough of them, the inner bubbles that I would say get collapsed due to the magnetic pressure. I'm using terms very loosely, so if anyone wants to rewrite this,
no kidding, yeah. So so for clarification, the red and gray blob in the middle is protons and neutrons.
It is all of the free hydrogen and other elements that were compressed due to the surrounding sphere of proton-based material.
And they're held together by what?
Well, they're being forced together by this magnetic, what I would say, pressure, because I don't know the terminology too well.
And then the other blob, the kind of avocado-shaped thing there.
Yeah, right. So that is the core, which I would say for now, but it is the center. It is where all the electrons would reside.
And it's held together by
leashes of springs, essentially.
Okay.
All right. So if these protons in the center are compressed into a solid sphere, then they create a point charge that attracts the electrons out away from the center. And what we are witnessing here is going to be a little bit revealing, is the birth of the sun due to the existence of the moon. Now, doesn't make a lot of sense, but I did just claim that the sun is composed of electrons, not hydrogen.
Sorry, I just need to clarify what you said there. The sun's existence is due to the moon.
Yes. Now I'm claiming this is the moon due to a couple reasons. One is that it has a heavier side on the outward post, and it is a more proton-based, higher ratio side facing inward. And that would answer why the moon always faces one way on Earth. Now I know we can say tidal locking, but I'm just going to make the arguing point, and I'm going to get back to it later. But I am claiming that the moon is inside this thing, and the sun is in a counterbalance with it. So without further digressions, we are going to consider the existence of a pure hydrogen planet. Since the center is made out of electrons and the sun is made out of electrons, I believe that this planet would most likely reside between the two. Whereas the planet with all that dead mass, the chargeless neutron, that would have a larger radius and it would stay away on the outside of the sun's circumnavigation. So we would see these two rotate around the center like so. This large shell around the outside edge is getting bigger and bigger, and remember the heaviest elements are on the outside. So the last slide in this logical path is to assume that all the solid planets would align based off their proton to mass ratio, which I went ahead and looked up the spectrograph results, and I saw that the Mercury was about 60% due to its excessive amount of hydrogen. And the other two solid planets, Mars and Venus, were about 50% exactly. The gaseous planets are made almost entirely out of hydrogen with a lot of helium, and that is why I believe they are closer to the center. And the moon is out here. But where is the Earth? The Earth is the edge, and we're not standing on it, we're standing in it. So my book is illustrated with this diagram that we saw in the thumbnail, which shows you the path that light takes through this ether. And remember earlier I said that the ether converges where the electrons are. So because the ether converges, the time it takes for light to get from one spring of ether to the other, transmitted through electromagnetic waves or however it is defined properly, that must remain. I'm sorry, I was rambling a little bit trying to figure out where I was going with this thought. Basically, the speed of light slows down as the ether converges. So I can prove that with atomic clocks at multiple altitudes showing that one ticks by slower. We already know that astronauts age slower at high altitudes. We think Einstein said it's due to speed. I'd say it's due to altitude. So yes, I am a concave earther. I believe that the speed of light slows down as you go into the universe. And because of that, I also believe that you shrink as you go into the universe. This is that experiment we saw earlier with the interferometer. I just sped it up like 18 times so that I can put it in this video. And I'm going to have to take a break here and ask if there's any questions, because I know I just kind of said something ridiculous.
Oh, so many. Oh goodness.
Dear.
The parch.
Let me, if I could, Craig, I know.
I need to organize my thoughts.
Yeah,
I tried to make notes, but
we've got some super chat questions. Maybe we could go there.
I need to take a Riley, so I'll be back in 2 secs.
All right. Take a Riley. We got Asylum says gravity is dead. All hail Dropity.
Yes, thank you. You are actually traveling in straight lines when you are traveling through space, and it is the Earth that is moving up. So if you drop the ball stays in a straight path, and the Earth comes up to meet it. Dropity.
Okay. We've got Asylum says again, what was this guy's scientific background again?
I'm a 6-time college dropout with about 4 classes shy of my bachelor's in physics.
All right. That's excellent. We've got, this is a good one. Throw the Dwarf is asking, ask how much damage I have to roll to break the ice wall.
There is no ice wall. When you walk towards the edge of the Earth, you simply end up on the other side of it. Like it's a sphere. You loop. It's circumnavigatable in any direction.
Yeah. So the short answer then is you have to beat 40 on a 3D 20 roll. There we go. Stringer News 1 says, for $5, I have a theory that beer and pizza are the fundamental units of the universe. Who wants to pay me to research this?
I think he should define it as such first, and then write the theory based on that.
Write a book. I'll get you in touch with Doug to get his same publisher.
I am the publisher, by the way.
There we go. Maybe you can publish Stringer News 1 theory on beer and pizza.
I am looking for an army of grad students, by the way.
There you go. Wouldn't you first need to become a grad student and then go past being a grad? That's generally
yes.
Never mind.
As the entrepreneur heart desires, it hires people smarter than itself to do that work.
Yeah, skip that. So okay. What RT96 says, what is the effect of this on the Vogon Highway?
I have never heard of that.
You've never heard of the Vogon Highway?
I have focused on very little things outside of this.
Craig, are you there? No. Oh,
he said no. Or
Craig is going to get his towel because he needs to be ready. Oh yes, General E. Shady says he's Lindsay Harris's upcoming star pupil. Base Desk.
Can I get a definition of who that is?
Lindsay Harris is a flat earther that has made up some interesting forces and things to explain flat Earth. And if you hate your brain, go watch Lindsay Harris. Asylum says, how does this theory incorporate SPDF orbitals?
Well, if we take everything we know, every data point about the heliocentric based perspective, all we need to do is just flip it inside out and everything still adds up the same. We just need to explain it with different forces.
Okay, there you go. Yep. All right. Andrew Stoll says, do you have any math to back this up?
Yes, and we're going to save that until we get into the nitty gritty.
There you go, Andrew. Prepare yourself to be mathed. Yes. It didn't work. Sorry. Holy Small says, boing, boing, and now you owe me a pair of pants. So
I will be happy to supply.
That was in dollars, not pounds. So pants to that person is the things that you wear on the outside. Where it pounds, it would be things that you wear on the inside.
Yeah, explaining Superman over here is really confusing to people.
He's wearing his clothes normally.
He wears his pants on the outside. Yeah, we all wear our pants on the outside.
Yeah, that's what you're supposed to do.
Yeah. Connell Connell Silverfur says that which can be claimed without evidence can be dismissed without evidence. Evidence of the springs, or they don't exist.
Well, I would like to prove that they exist directly, but I need more research done. I'm in the conceptual stage. I've got a bit of math, a bit of data points, but I need to do more, and I'm well aware of that. But I'm also ready to start talking about it. So,
all right, let me finish these super chats here. Bella Charge says you heard it. Hashtag Donut Earth.
I resent that. I don't know why this has to fall into such a sarcastic category, but I understand this is a alternative model. Like, I've spent my whole life getting that kind of feedback. So
it's not donut, man. It's
that. How would gravity work on one side and not the other? It's just simply impossible.
Well, we will find out how it works on your anyway. Asylum is wondering if you completed the first semester. You got a tough crowd.
Of college?
I'm guessing, yeah, college.
Well, I have an associate's in science at least. I just was never able to upgrade that to the bachelor's. I spent a lot of time arguing in class, and my grades showed that.
I see. That doesn't, arguing with professors doesn't get you far. All right, Penguin 95 for £5. He wears his pants on the inside. It says, hang on springs and aether with the electrons in the middle. Wouldn't that have shown different trajectories and speeds when they collided particles at CERN?
Well, the assumptions at CERN are that the electrons are there. But then again, we also have no idea, no way to prove where an electron is, because every time we zoom in too much, it vanishes into a possibility. So
Schrodinger's cat. Not Schrodinger. Wow,
the double slit.
No. The uncertainty principle. Heisenberg's uncertainty principle, yes.
Right. So if we don't know where the electrons are, how can we be certain that we're looking at their activity? What I think is we're looking at the reminiscent electromagnetic trade-off. Like I said, we're in a very conceptual stage, but
all right,
we can redefine a lot of things here.
It probably will be necessary. Stringer News 1 says it's not April Fool's Day yet.
I was a month off. Blast.
Dang. And then Hugh Jars. Do you know Hugh?
I don't know many people.
Hugh Jars. He says, what drugs is this guy on? And can I have some?
Well, I spent the better part of my education on Concerta and Risperidol. So if that answers your question, that's how you overclock yourself. Uppers and downers simultaneously.
Okay. Indy Tiger is wondering what happens when a spring breaks.
I don't know if that's possible. That seems like it would just throw the whole thing in a loop.
It does sound a little bit like the weak force. Just saying.
However, I'm saying that it fundamentally must exist, or else if the spring were to disappear and the electron and the proton could recombine, then the neutron, wherever it is, would have to vanish simultaneously as the anti-neutron, because they exist in the same realm. An interesting thing that I thought about once was there's nothing holding neutrons on except the cluster of the atoms. So there should be neutrons flinging off, and the radius of the universe is compressing. So there is an end. It's just not going to be for a while.
Okay. William Foley says, I don't know if he disproved gravity, but he has discovered handwavium.
I am of Italian descent, and I cannot speak without moving my body.
All right. And Mr. Unite for
Wish.
Mr. Yes. Mr. Unite for the Children says he doesn't know the Vogons. Let me read him some of my poetry to punish him.
No.
You paid for it. Let the man speak.
No, we will not be listening to Vogon poetry. Thank you.
No Vogon poetry, Mr. Unite for the Children. I don't care. It is not going to happen. All right. Final one for now from Asylum says SP DF orbitals are on atoms. How do you explain them?
I realized that halfway through my BS answer, and I am going to have to revert back to the CERN answer, where we are not sure where the electrons are. We know what it looks like, what our experiments tell us, but those are based off of our interpretations. If we interpret that the electrons are somewhere else, we could start focusing on the actual nature of electromagnetic waves.
Every computer science major in the world just had an aneurysm.
I intend on hurting people's feelings.
No, you literally made their brains like rot at that.
Yeah.
Okay.
Well, if there's any of them out there that didn't suffer, then I would be interested in hearing what they have to say about this. because I need to find someone who's smarter than I am to complete this.
All right. And then what about SPQR orbitals?
I failed chemistry several times.
Oh, that's all right.
I did not-
You would have learned about that in Latin class. Okay, Craig, do you have any questions?
Wow. There's so many, really. Can you explain how ions work to me?
Not currently.
No, I wouldn't have thought so.
Okay.
How do you explain chemical reactions that share electrons between valence shells and stuff?
Well, like I said, these shared electrons would have to be reinterpreted as entangled ether, and that's really the only direction, and that's as far as I can take that question. I really am poorly educated when it comes to chemistry.
So what would happen if we were separating H2O into its constituent elements? How would the transfer take place?
Well, you would have, in a sense, a knot between two ether, and they would remain entangled until they unwound themselves. So that could, in a sense, explain the nature of what we see experimentally. And like I said, this is not my subject, so I'm just guessing based off of what I've already known.
Okay. Electricity is a bit of a problem in your model,
right?
Yeah. Computers work though.
Yeah, computers definitely work.
Well, everything still works. I can't claim that something that we see isn't there. Yeah, it's merely an interpretation.
Your explanation of how electrons transfer their kinetic energy essentially doesn't work in the confines of how electricity is transferred between conductors. They're kind of incompatible with what is actually happening on a subatomic scale. So I just, in your model, how would a charge get from point A to point B?
It would have to be through an electromagnetic wave. We know that when a beam of light intersects a piece of metal, I think this is the photoelectric effect I'm trying to describe here. It turns into electricity in a sense. But if you were to excite a piece of metal enough, it could turn into another beam of light. So if it was hot enough, I assume this is how it works. Could we restate the question? I'm not sure where I was going with that, to be honest.
Oh, but it's just the general flow of electricity, how electricity gets from point A to point B. I don't understand how that physical mechanism works with your model.
That's electrons moving, and how does that not happen? It's protons
like
now move?
Protons are still there. It's the electrons. It's basically. It's going to take the second edition to answer that question. I've made it really clear that I'm not really well educated on what happens on Earth. Sorry, I'm not well educated on what happens on the Earth's surface, especially on the subatomic level. I'm merely trying to reconceptualize the grand scheme of things, and I had to include the inside-out atom. So there's going to be somebody eventually who works with me to help me figure this out, and that's going to be a question I have to answer much later.
Okay.
All right. I mean, I've got a lot of questions about how the model works with gravity and stuff, but I think that's more we're still to get there. But I'm still kind of trying to digest what I've heard there too, and I may have a few more notes come back to me. All right.
Yeah. All right. Well, let's maybe you have more to go. You had like a second part coming now.
Yeah, let me go through the tabs here and see what I had lined up.
Wait, while you do that, let me get just a little input from Mark Steele on how atoms work.
Non-ionizing radiation is the natural occurring radiation field that is supposed to not cause ionization. However, that only applies to natural occurring and not man-made, and that's how you can cause ionization.
So what's ionization?
Ionization is where you knock an ion off an atom.
There you go. You knock an ion off an atom. So says Mark Steele.
You knock an. What's an ion?
An ion. There's an eon and an ion. One's positively charged. One's negatively charged.
Okay.
All right. So I know you didn't hear that, Doug, but Mark Steele says that ionization is when you knock an ion off an atom, and that there are two types of things. You have an eon and an ion. One is positive, one is negative. Maybe you could work with him.
Well, like I said, I'm open to hiring people.
Yes. Well, Mark Steele is in need of money. His
Well,
his scam has gotten a little dwindled lately. Anyway, yeah, do you have I mean, we have more questions from the audience.
I'd love to just keep answering them.
Oh, all right. Then I will go let's see. I mean, there's going to be some all right, Asylum says that he's looking for smarter people. He's volunteering his goldfish.
Well, then, I'm interested in meeting this goldfish. He's got such a good recommendation.
There you go. Okay. Oh no. Oh, Penguin95, is that? I believe that does look like it may be Vogon poetry.
Oh, here we go.
No, don't read it.
Oh,
It will break the internet.
I will read it gently. Oh, Freddled, grunt
No.
bugly, thy micteriations are to me as plurtled, gabbled clutchits in midsummer morning, unallured bee.
You do realize that even though it comes from an alien species, it falls under the preludes of the Geneva Convention because it is cruel and unusual punishment.
I'm sorry, people. I did it gently though. All right, Golden Brisket for $2 asking, what's the difference between eons and ions?
Did we already answer that?
No, we asked what's ionization. He's asking what's the difference between eons and ions.
Well, from what I've heard, one of them is missing an electron. One of them has an extra one.
So says Mark Steele. But in reality, an ion is either positive or negative charge, whether it's a cation or an ion, and an eon is a long amount of time.
An ion is just some, an atom that doesn't have the right amount of electrons, really.
It's a mismatch. Woden Toad is wondering, how do breeder reactors work?
Another thing I would need to define before I answer.
Yep. All right. So you got a few holes. So we've got Mike Billars.
Hey, Toon, what do you think would happen if I showed him the video of the inside of a tokamak fusion reactor?
Ooh.
You mean that blue light? I've seen that. It's beautiful.
Okay.
Many issues with your model because with what's going on there. Many issues.
Yeah. All right. Mike Billar says, looks like MC Toon didn't have enough to do today. So he hired a dude to put on a jacket, get effing blitzed off vodka.
Exactly, Tony.
And play Mad Lib with a physics book. Oh, Doug, I love you, man. You're awesome.
I'm here.
Justin, Greek last name that I can't pronounce, says how, and I'm sorry, if you want me to actually pronounce it, like, tell me how. How would Aether explain half integer spin? Needing 4 pi rotation to return, electrons can pass without making knots. Even with his model, the curvature of inversion would have the wrong Escherness.
Escherness. Could you?
Escherness.
So
yeah, I don't know what that word means.
Yeah.
Symmetry. It seems like that's the word that would fill that gap there. We're back to Mad Libs here.
That could be Mad Libs. Could be. Ooh, Stringer News 1 says the person that helps you figure things out. You mean a psychiatrist?
That didn't work.
It did not work. The voice of experience there. Generally, Shady says his parents must be so proud. Nope, I'm lolling hard.
No, I want to hear it, please.
That's what he said. That's what he wrote.
Yeah.
His parents must be so proud. They're proud that I finally got onto a YouTube channel. They're otherwise pretty stressed out over this.
Doug's parents, you are saints. Thank you very much. Take good care of him. You're doing well.
Right. So, if you don't mind, I've got a couple of questions.
Okay.
Just going back to his presentation. What could you tell me what you think the Mux and Morley experiment was actually doing?
No.
Did you read it?
No. I've never heard of that either.
The Mux and Morley experiment, you had that up as part of your presentation.
What did it look like? I can find it. Reference it visually.
Well, they used an interferometer to.
Oh, Michelson and Morley. I'm sorry, your accent. All right, so
what was the Michelson-Morley experiment actually designed for?
It was supposed to, from my interpretation of everything that I've learned, it was supposed to determine the direction, the master direction that Earth was taking through space by catching the ether wind, basically in a sense trying to see what direction we were going through, but inadvertently disproving that the ether existed by saying that, well, there is no ether because it's undetectable. There must be something else going on, which Einstein stepped in.
You're kind of
parts.
Right, I guess.
Yeah, parts of that were right. So the point of the Michelson-Morley experiment was to test if there was an ether. What was hypothesized was if there was a medium called the aether that light needed to propagate through, and it permeated all the space, then as Earth rotated around the sun in its orbital path, it would leave a wake. The same as if you put your hand out of a car window, you feel the drag on the air. And what they hypothesized was that drag would cause light to come in at a different speed based on if you were going into or against the perceived drag of the ether. So they tested it at two different points in Earth's orbit to see if there would be a different interference pattern. And what they found was there was no interference pattern change, which pretty much blew apart the hypothesis of there being an aether.
Right. But then when we turned it vertical, we saw that the interpretation could go that the Earth is accelerating upwards at all points, or that it's accelerating downwards at all points. So whichever one, we would need atomic clocks to determine exactly which one.
The Michelson-Morley experiment could never determine if the Earth was accelerating upwards or downwards.
Well, it was to catch an ether wind, and now when we rotate it up and down, we see that there is a somewhat of a change along the vertical axis.
Yeah, that was another thing that I was going to ask you about. The experiment that you were showing and the one that you recreated, are you saying that what's happening there is not the predictions of the current model that we have?
Correct. They could say that the change in the speed of light, or the acceleration of speed of light down towards Earth, could be due to gravity, since the E equals mc squared suggests there is a mass associated with the speed of an electron or a photon.
Yeah, but the interference pattern that you got, I don't understand why that would be outside of the predictions of the model that we have.
Because that, no matter what you do with that device, it should show no change in interference because there is no ether. If there was an ether...
No, that's not what an interferometer does. An interferometer simply shows an interference pattern if it's been moved, because it registers a change in acceleration.
Right. So why does it show?
Do you know the Sagnac effect and how that works within an interferometer?
No.
So let me. Can I share my screen?
Can I say before you do that? I think we do expect there to be a change in that interferometer when it's vertical because of gravity, and the Pound-Rebka experiment was the first one to confirm that. But
sorry, continue.
Craig is gonna present here in a second.
So, right. So let me just. Right, is that sharing?
Oh.
No, hold on a second.
Yeah, it is. I see it. At least on the Zoom call, at least.
Our people at home don't. There we go. Yeah, they do. No.
Okay, right. So this is the inside of an interferometric fiber optic gyroscope, which uses the Sagnac effect and the speed of light to show if there's movement. Okay, so this blue box fires a beam of light, and it's split into two paths. The path the blue bit's going and the path the right bit's going. Now, if the instrument itself, the whole thing, isn't moving, what will happen is that when the light recombines at the other side, it won't show an interference pattern. There'd be no interference between, because it's taken the same amount of time. But if the entire instrument is moving, like when you were moving the entire interferometer that you were using, that will literally change the distance that the light has to travel around one of the paths and create an interference pattern when it goes back. And that's the prediction that we have. That should happen. If you're, whether it's vertical or it's horizontal, if you're moving an interferometer about, because it changes the path that the light has to travel, you are always going to expect an interference pattern. And like Toon said, horizontally, you have to take into account the energy lost by the photons trying to escape the gravitational pull, and that's what you would see in the Pound-Rebka experiment. So what you were showing there is is within the predictions of the model that we have already.
However, the current model guarantees that the Earth is moving. And if that were true, then what you said would show that the Earth is moving through space with the interference on the horizontal plane.
It absolutely does. Thanks, Bob.
So why then do we have special relativity? Wasn't there an issue with it appearing that there, no matter what direction we pointed it, and no matter what rotational point around the sun we were at, or around the galaxy?
We need to clarify a little bit. The Michelson-Morley experiment was not what Craig just showed. He showed more the Michelson-Gale Michelson-Gale experiment where there's a a ring.
Yeah.
Michelson-Morley, there's like two arms going opposite directions.
But it's the same concept.
Yeah,
they're similar, but they will measure different things.
Yeah.
Okay.
But,
So
my point is that if an interferometer is moving, then that's going. It's going to show an interference pattern.
But the one that he showed, Craig, was not the ring style. It was the Michelson-Morley style.
His was
So it had one arm going horizontal, one arm going vertical. So we would expect, even when stationary, that the one that went up and down would have a different route because of gravity than the horizontal one.
Yeah.
I think.
So I'd be interested to see that version of it on the vertical plane and how it would react to the up and down motion, or the rotational exposure.
Yeah. So, okay.
Now there's another part that I want to get into before we call this quits for the night.
Okay. Well, let me see if I have a couple other. Jose Reyes is wondering if you do children's parties because you're hilarious.
Thank you. I used to be an Uber driver, so entertaining individuals is my profession.
Yeah, I also did drive drunk people around for a while.
I just drive my wife insane.
There you go. Good job.
Does it pay?
And finally, this is PhD Tony, who uses gravity on a daily basis for his job. Says, how does your guest explain the process of nuclear fusion and fission? Where does that energy come from?
It must come from the energy it required to entangle the atoms to begin with. It's stored in a sense, and that's as far as I can take that answer.
Where's it stored?
Remember when I said during that tiny Big Bang that there was an explosion, but there's a collision? There's basically this giant mosh pit of all these atoms mashing together and getting entangled. Once it starts to rotate, then it sorts itself out and sort of.
So for nuclear fusion, for instance, the sun. It happens when there is an extremely large amount of mass that collapses under its own gravitational force and overcomes all the other forces that are within atoms and makes them fuse together. So hydrogen becomes helium and then releases what's left over as energy. Okay, that entire process of that energy being released because of the reaction, that entire thing doesn't work with your model. Where does that extra energy come from? We can use spectroscopy and measure the different types of energies and radiation coming from the sun, and we know that they are specific byproducts of nuclear fusion. So how does that fusion process work in your model?
Well, in particular, the sun in my model is not composed of hydrogen and helium, although it does show up on a spectrograph as such. It's because the tying together the entanglement of the electrons at the upper end would show up as a bonded electron, but it would interpreted on the spectrograph would appear as a helium.
I mean, that's a pretty large claim to say that the sun isn't hydrogen. I mean, we sent probes there. It's very hard to just deny all the knowledge that we have and the understanding that we have. We can literally see the byproducts that come from the sun, and we know that these are the byproducts that are expected under nuclear fusion. So you would have to explain where all those byproducts come from if that's not coming from a hydrogen turning to helium nuclear fusion reaction.
Well, in a sense, we're determining our interpretations by observing the experimental results. So when we send a probe out, look at the sun, and we see what happens, we're matching that to what we think it is. And basically, all I'm doing is just conceptually assuming that it can't be made of hydrogen in order for this model to work, and we'll have to verify that in other indirect ways. So I can't claim that I can't prove that the sun is made out of electrons until I can get to experimental results that are indirect. So, like I said, this is the first edition, and it is not a graduate.
Okay, so if, sorry, just off the top of a minute. So if the sun is just a big collection of electrons, where does the energy come from that we receive from the sun every day?
Photons.
Right. They are ripples in the ether that travel as energy, packets, photons, if you will, in the old model. But in this one, it's essentially just an electromagnetic wave traveling through the ether. And the energy originated during the Big Bang, when wherever this energy came from integrated itself and to allow matter to exist. So the energy was given, and that's as far as I can say.
Okay.
So,
let's get
back into it.
the next segment here.
All right,
there was just one more thing I wanted to broach, and if you don't mind, and do you know what the recombination event is?
No.
Right.
All right. Simple enough.
It kind of explains how a lot of the matter in the universe came to be at the point where the universe became cool enough for electrons to bond to protons and stuff.
Right.
And we can see that happening, or we can see when that happened. Right. We look out into the universe and we can see the cosmic microwave background radiation, and that is literally an echo of the recombination event, the point when protons and electrons and started to combine to be able to form primordial elements. And I was just thinking that in your model, there's no explanation for the cosmic microwave background radiation and how we know that formed.
Well, I'm excited to tell you that there is. So the micro background, sorry, what you said, the
cosmic microwave background radiation.
Can we come up with an acronym real fast? So I don't have to.
CMBW.
Thank you. Well, the CMBW was originally discovered. It was confusing because it was coming at us evenly in all directions. And that doesn't make a lot of sense, except for the explanation that the Big Bang happened and we were constantly traveling away from all points at all times. The expansion,
yeah, that kind of makes sense, yeah.
But if the source of that radiation is the center, and it is a basically snapshot frozen in time because it's taking millions of years for light to travel to get to us, then what we're looking at is the center during the explosion, and it is coming out from the center towards all the points, all the observers on the Earth, so that the background radiation is consistent because it's all in the same place. And we're just
wait. So the background radiation comes from Earth?
It comes from the center of the cosmos, which is within the Earth in the inverted model, where the electrons are, and they look like stars.
Right. Okay. But then that wouldn't explain the fact that we can see a perceivable redshift in the cosmic microwave background radiation.
That just depends on if the electron is moving towards us or away from us.
Yeah. But again, that doesn't make sense in your model because...
Well, in my model, the electrons are constantly in this chaotic motion going around the center, closer and further away from the center. Sometimes they pass through it and the images become distorted. They look like nebulas or supernovas, depending on their direction. But when an electron is approaching the center, it's getting larger. The image is becoming stretched due to the things that we're about to discuss in part 2 of this presentation. And it all makes sense once you really understand the model.
Okay. All right. I've got so many more questions, but please do move on.
I won't prolong their wait. So chapter 12 is the nature of light. It's my favorite chapter because it just directly deduces how light should work based off of what we currently know.
So want to present your screen?
Oh, sorry. At least I got it back here. 1 second. Zoom meeting, share screen. All right. Share. Perfect. Okay, so where are we? Let's zoom out. So here is the beginning of chapter 12. What we're doing is taking the old model's angle of the beam of light that it makes with the surface of the Earth based on the simple geometry of the straight lines and the circular surface. Then we take that angle and we just flip it into the inside and we just notch the edge of this circle to see where the light should be pointing if it's coming from the sun. So what we see in step 1 here is all these angles pointing towards the sun in some kind of fanning motion. Now we'll go to the next page and do the same thing with the opposite side of the Earth. If we take these lines of altitude that we discussed earlier, then we can flip them and match the angle that they make with the shadow created by this Earth within the sun's light.
Now, do you not have a problem that looks like a butt?
I know it looks like a butt.
Okay.
And I've often seen.
Well, you see butt, I see boobs. I mean, it's just says a little bit about us, MC2.
Yeah,
You know.
I guess. Yeah. To each his
That is-
own, I guess. In the chat, I guess.
Butter boobs, chat. Butter boobs.
Yeah, which one? I guess.
Well, the question is, where's the? Never mind. All right. So
Actually, now you know what? I see a Pac-Man.
Okay, that's a little bit more PG. So
Waka waka waka.
Somebody said they sees a peach. But I see the butt is farting night.
that is the proper interpretation.
Oh, we've got a lot of butts. Craig, you're kind of.
Yeah, see, the day is like when you're eating the Rogan Josh, and the night is when you wish you hadn't.
Regardless of the secondary interpretations, this is why this is how we would explain night and day in the inverted model. So moving on, we continue by connecting the dashes and then just assuming with smooth lines where the light should travel in this two-dimensional cutaway. So now I want to focus, if I'm remembering the path of this book correctly.
I mean, you did write it.
The shadows of the moon. So if we place the moon in 28 equal distance locations around the center, I know this is a really off-centered image, but just bear with me. I use Google Docs or Google Drawings to make it. Anyways, we can use the location of the moon with respect to these lines to determine what side of them will be shadowed, and then place individuals, observers around the inside of this globe to see what they would observe. So imagine that you're standing at the bottom of this diagram. If you looked into the, I assume it would be the west, you would see the sun on the horizon, even though it's above you. And if you looked in the opposite direction, you would see the full moon rising. And we know that when the moon is setting at the same time, or the moon is rising at the same time the sun sets, that's a full moon event. However, it's not exactly specific, but we'll save the discrepancies for later. But so far, this works, and we'll continue. Now, we have summer solstices, winter solstices. This is all very easy to explain. This book, by the way, if you wanted to, you could just read along with it. It doesn't cost anything. Review it later, but I'm just trying to fly through it just to just get the idea that, I've taken an attempt to explain a lot of the things that would be, general questions in astronomy and how the universe works. But when it comes to chemistry and electricity, like I said earlier, we're just going to have to wait till the second edition comes out. But I'm really just flipping through the pages here to see anything worth mentioning. But this does have an explanation for lunar eclipses, solar eclipses, and the eclipse season. Everything needs to line up just as it would in the current model. We just have to invert it. So a couple of things in particular that I like is thinking about the eclipses. So when we have the sun the moon casting a shadow on the earth, that is because the light from the sun is traveling all the way throughout this, and it is lighting up the moon in a sense, but only the red beams can get to the moon. And that is because, or the reason that they're red is because they are the same photon traveling twice the distance in the same amount of time. So the wavelength must be doubled and the frequency must follow suit so that it adds up to, multiplies up to become the speed of light. So,
sorry. So just to clarify there. So if someone is standing where you've got that eye and they're seeing the sun, the moon lit up, it's because the light has traveled all the way around the inside of the earth and gone round to the back of the moon.
Right. So, and because the distance is so long in the same amount of time, that is why it is red only. And the blue light that you see going straight from the sun to the earth's surface is blue. It's half.
Yeah, I'm going to quote someone in the chat, Stringer News 1. What? Why?
Why what?
just why?
Why? Because I couldn't prove it wrong in my own head, so I had to follow through and find out for myself.
Yeah, but why would the light take that path?
Oh, well, that's a much more specific question. It is because, and I think the next few pages will answer it. So, does that answer it? So the path that light takes in the current model to get from the sun to the earth is about 93 million miles, or 1 astronomical unit. That's from the sun to the poles. The difference between from the sun to, or the sun to the equator, the difference with the sun to the poles is about 0.0043% difference. So in the current model, there would not be a significant different number of photons going from either path. So it's negligible. With that in mind, going to the next page, in my model, the path that light must take to go from the sun to an observer at noon versus the sun to an observer at sunset would be, from what appears here, twice that distance. So to explain the redness of the sunsets and other color shiftings regarding the horizon, it is due to the nature of light, and it's deduced from those previous pages that started.
Right. Okay. Yeah, that kind of explains the observation, but it doesn't explain the mechanism behind why the light would choose to take that path. So am I explaining myself right?
Yeah, I understand now. Okay, so the reason is when we are observing light in reality, we notice it goes constantly in the same speed in all directions. But if we are looking at it conceptually, we know that it should change in order to maintain sort of a functionality of time. Light has to slow down in order to maintain the identity between wavelength and frequency. So as you get closer to the center, the speed of light is slowing. So if you were to send a beam of light horizontally, the half that goes up is slowing down, and the half that expands downward is speeding up. So when it leaves the sun, that one beam of light that is directed straight down goes straight down, but the beams that are fanning out, which is shown in the covers and all these curvy lines at 1 second, these ones here, those are the path that light takes within the earth. And it's because that it's like well, it's just deductions. Exactly why is going to have to be answered a little bit more intricately, but I think I did the best I could to explain it so far. If I haven't, please refine the question a little bit more. I'd like to keep focusing on this one and get
we need to get to the gravity of the situation here.
Well, I would like to start off with my problem with gravity. Gravity itself seems to contradict the law of conservation of energy. Let's do a thought experiment, and I've got visuals to back this up. So 1 second while I scroll through here.
So you say that gravity contradicts the law of conservation of energy,
right? And I'm just about to where I knew this was going to happen. So let's focus on this here. A thought experiment: two chargeless masses in the universe all by themselves. The current formula of gravity says that based on the distance between them, they would have a force, not necessarily easy to define, but nonetheless some kind of force that pushes them together. The closer they get together, according to gravity, the stronger that force becomes. So there is an acceleration that pushes these two chargeless masses together. But not only that, it's an exponentially growing acceleration based off of distance. Now that makes sense if we're talking about charges, but gravity doesn't talk about charge. It only talks about mass versus attraction. So this attraction, this law that suggests that these things come together also kind of suggests that there's this infinite fuel on these metaphorical rockets that push all mass together. And the question about where does that fuel come from is where dark matter and dark energy seem to take over. But my issue is, when we pull up my slideshow, is this chart here. When we test gravity on Earth, it works because we verified it. We determined it experimentally on Earth. We determined the constant of gravitation. The constant of gravitation. Am I saying that right? We figured these things out on our Earth's surface, or at least on the moon somewhere very close to us. But the further we get into space, the less and less those equations describe what we see. So when we're talking about the spinning of a galaxy, gravity says that this galaxy should be spinning. It should have a lot more mass there in order to hold it together because it's spinning so fast. These galaxies 100,000 light years away are spinning at 500,000 miles per hour, whereas gravity suggests based off of what we can see, the number of stars and whatnot, they should be spinning much, much slower. So gravity fails when we try to explain the motion of the star, something we can't verify experimentally. We have to deduce it versus observation alone.
Well, I mean, it doesn't fail. Newton's gravity, for instance, doesn't even try to explain anything outside of a local system. Einstein's explanations are more about explaining what happens under relativistic effects. What we see in galaxy rotational speeds, and that can be explained by the theory of dark matter, and that there is an obvious mass in the universe that we're yet to identify. It's that there's no problem with gravity.
If I could hypothesize a source to that mass,
yeah,
it would be the density of flat earthers' brains.
definitely.
Well, if it depended on mass, then that would be a good argument.
Yeah. Okay. Continue.
Well, anyways, so that is the issue. But if we try to explain gravity using only the notions that I've laid out so far, we see that we have one part rotational, centrifugal force. One part is this attraction to the center that counteracts the centrifugal force to give us this homogeneous 9.8 all throughout the Earth's surface. And
it's not quite homogeneous.
That's I was going to point out. You actually weigh 0.04% less at the equator than you do at the poles. There's a difference in gravitational acceleration at several different points around the Earth, mainly the difference between the poles and the equator. However, depending on the mass of certain elements and stuff under the Earth, there is actually noticeably different gravitational acceleration at different points all around the Earth. And this is what one of our subscribers, PhD Tony, kind of uses in his job, is the gravitational acceleration at different points on Earth to determine where certain minerals and things are. So although it is close to 9.8, there is a difference in gravitational acceleration, most noticeably a difference between the poles and the equator.
Well, here's the thing about the force of gravity throughout the surface of the Earth. It is not arguable. It is an experimentally verified result that we have to apply to whatever we're trying to conceptualize. So what I'm saying is, based off of these three variables that I have on my screen, we know what the force of gravity is at various points in the Earth. Apparently it's not homogeneous, but I'm interested in exactly how that works. We know the rotational velocity of the Earth with respect to the stars because they are essentially fixed in space, and we are definitely rotating around them one revolution per day. What we don't know is the actual radius of the universe regarding a one-dimensional measurement. We know that the Earth has a 25,000-mile circumference, therefore there should be a 4,000-mile radius, but my theory suggests that when you go into the Earth, your measurements literally shrink based off of how close you are to based off of your ratio of radii. So we don't know exactly how big we are. We don't know how far away from the center we are. All we know is we have a 25,000-mile circumference, and I can use those bits of information to actually verify or at least mathematically determine how big our radius truly is. And I'm going to do that.
If we know the circumference,
then we know the radius.
We know the radius. There's only one radius that works.
One thing that I failed to present, during this presentation is that, and you're about to hate me for this. Do we have any flat earthers in the actual chat, or is this all?
There's Gary Webenenga there who, and I think, honestly, my finger keeps slipping and accidentally timing out. I don't know what's going on there. It's weird.
And I think is helmet B
possibly
says as First Chronicles 4:10 helmet B. I don't know what that is, but okay.
Anyway.
So you said that you didn't. You wanted to understand about how there's a difference in gravitational acceleration.
We'll get to that later. We need to get
through it. Yeah, it's getting past our bedtimes. All right. So on my theory, after a bunch of reading and open-minded convincing of yourself, suggests that the vertical axes that leave the Earth's surface as plane, converging in the middle, remain parallel, which is a similar definition to the Earth is flat. So what I'm telling you is that there is an infinite amount of space within the Earth, and it acts like these geometrical markings that you have on my screen. The circumference is always going to be the same because those markings being parallel and equal tell us that shrinking measurements maintain this vertical parallel x-axis. So with that being said, the Earth acts flat, but light does not
out
straight.
Right. So my main problem with that is, the entire science of seismology, really.
Well, here's where it starts to make a little bit more sense. That line that I told you about, that curve that I would be able to predict is, once I'm trying to fill this in while I look for my favorite diagram. So here we go. That is the, that rendered flat surface that I told you about. If we take the Earth and peel it like an orange and just flatten it out for 50% of its surface, then we can use that graph, that x-axis, to measure the height of the altitude of the beam of light. Now, the red one is based off of the predicted geometry of the current model, and the blue one is mine. So if we were able to do a large enough experiment, then we could prove that this is the nature of light and the Earth itself.
Okay.
Why else would light stick to Earth and then accelerate away from it, finding its original trajectory?
Gravity. So in
Gravity would explain the first part.
in 1919, Eddington explained that exactly using the predictions for space-time and the experiment to confirm those predictions. So
you're telling me that somebody is able to predict this line and explain it using the current model, this curved line of light?
Yeah.
I would love to read this.
I mean, they did the experiment in 1919.
So it's common knowledge now that light bundles up at the horizon. Is that what you're saying?
No, it curves due to mass.
Yeah.
Right, due to mass. So if mass is present, obviously the first half of this prediction makes sense. But why then does light accelerate and then find its original trajectory just off put by a few thousand miles?
Do you mean diverge instead of accelerate?
Yeah.
Right. So we have a downward facing curve here and then an upward facing curve here.
So what they found in 1919 was that using the fact that there was an eclipse, they were able to look at the stars behind the sun and see that they diverged the predicted amount based on what they said the curvature of space should be.
And I have an explanation.
So what happens is that the mass puts a pressure on space-time, causes it to light does travel in a straight path, but it travels in a straight path on a curved space-time,
right,
which makes the position of the stars appear to diverge from Earth. And that's what's happening there. And obviously gravity falls off with distance. That's why it's Fg equals gm1 m2 over r squared. The distance squared, it increases as the force increases based on that ratio and falls off based on that ratio. So the amount that light diverges based on the distance towards it is going to drop off the further away it gets.
Right, that makes sense. But that it doesn't explain why light would then accelerate, not just lose its attraction towards the surface.
Light doesn't accelerate. Light never actually changes speed.
It changes direction. It doesn't accelerate.
Well, if we look at the top of this diagram, we're assuming that light is not affected by the gravitational pull of the Earth whatsoever. If we look at the bottom half of this diagram, what I can show you cut off by my toolbar suggests that yes, the gravity does suck the light down. But if we cut off the bottom again, why does light accelerate upwards away from it? And that's what I'm going to have to prove happens before I can continue to claim that this is the way it works. But with the single data point of Chicago across Lake Michigan at 50 miles, we know that there is definitely some kind of attraction towards the center, and it's consistent. And
okay. So what you're seeing over Lake Chicago isn't gravity bending light. That's simple Lake Michigan. Sorry, that's simple refraction of light. Yeah, that's nothing to do with gravity bending light down towards the other side. That is simply to do with the refraction. It's like you were saying, a superior mirage. It's a mirage. It's nothing more.
Well, a mirage would explain the waviness of that image
and the change position as well.
The image.
Yeah, the fact that because light, as it travels through a denser or a change in temperature, as it gets towards the more dense medium, it bends down towards that medium, allowing you to see further around the curve. That is what refraction is. That's what happens. That's the prediction of our model. Right. Seeing that is exactly what we expect to see with kind of standard refraction. And I think it was like 54 miles. So it's less than 1 degree that light has to bend for that to happen. So it's not even that far off of standard refraction.
But it is a 75% discrepancy of what is predicted.
No, it's not. There's no discrepancy as to what predicted. The predictions of refraction says that would happen under the conditions that were there.
The conditions of refractions rely on entropy within the atmosphere. If you were going to say that hot air and cold air can bend light, then it would have to depend on a absolutely perfectly translated image going through random pockets of air that are hot and cold. And
no, there's a gradient. There's a gradient. It's at the bottom, it's colder.
But there's no way on a clear day you can see a perfect image, which cannot rely. So you cannot program this to be recreated by a computer.
Yeah, you can. It's actually done. I can get that up right now from MidWest.
We can bring that up. Yeah, it's not that hard. not
Well, what I'm saying-
not understanding it, I think, is probably
I'm
just
saying
your
you can
problem.
program an explanation for the experimental results, but you can't explain them convincingly when the concept itself is depending on randomness. This
It
is
is
a,
not-
It's not random.
It's
though.
not
It is
depending
what
on
you're saying.
randomness.
What you're telling me is has to do with the different densities of air. It would explain it marginally over a very short period, but over 50 miles, you cannot take an image, 100 million trillion billion beams of light and
Yeah, you
translate
can.
them all perfectly. And
Why
I would
not?
prove it. I would prove that experimentally. I can't do it right now. All I can do is conceptualize and claim. But
it's been done.
I'm telling you, it's been misinterpreted. I'm telling you that you've experimented.
Would you like me to show you the predictions and the thing that was made?
I understand
think
what
we're
you're
off. Yeah, we're
okay.
9 o'clock hero asks, what's your best pickup line?
Hi.
Okay. So we need to. I mean, people are on the edge of their seat for this replacement of gravity. That with predictive power. So, can we? Are we getting to that?
We have established a concept that can be proven. And I'm telling you, I've dedicated every resource I've had over the last 10 years to at least explain it. Now I need more help to actually verify it. I have many experiments, many devices that are ready to be built and ready to go. I've actually got an interferometer being 3D printed within the next month. So what I need is more attention, more work going into this so that we can actually say it's true or not with unquestionable certainty.
But the problem is that.
All right, listen. I know what your problem is, and if you keep repeating it, it's not going to get anywhere in the conversation.
No. In general, the problem is that all your premise is going off of that. There's a problem here, and we need to fix it. Where there is no problems, like there's no problem with refraction. There's no problem with gravity explaining the observations we have.
And we were disagreeing.
And I don't want to sound rude, but a lot of what you're doing is based off of quite basic misunderstandings of physics.
Well, they're not misunderstandings. They're redefinitions. I am having to rebuild this entire model so that it can be completed. And I've done the first step. I wasn't prepared to come up with this program and show you and have all these numbers flying at the speed of light. That's not going to happen today. What's going to happen today is me breaking the ice and some other people thinking more than what my opponents are thinking and saying, okay, maybe this could work and we could actually get somewhere with some verification.
Yep. Okay. So why are you trying to redefine things that are already defined and don't have an issue, though?
Why does science exist? For their understanding of the nature of the universe.
You have a point. You have a point, right? Questioning things is perfectly valid. But when you are presented with, when you find out the answers, sticking with the question and asking it again and going off the other direction, that's kind of the weird thing.
The point that I think Mr. Craig is missing is that if gravity had any effect on it, if refraction had any effect on it, then once that effect had gone away, then this trajectory would go straight. And an observer on this side of space would be able to see what's happening with this person's eyes.
But I don't know if that's what that two direction curve. Where did that come from?
That is a claim that is based off of the deductions of chapter 12.
That's your claim.
That's my claim, and that's why I brought this research paper.
But what actually happens in reality, though?
That will have to be determined by these experiments, large scale surveying of.
But we've already done experiments on how light moves and bends and stuff.
So could you have people at different spots look at, say, the ISS, which is orbiting, and you can see from
the ISS is at a fixed altitude. What we need is a changing altitude, an object that is observable and is changing its altitude so that it can be marked at various timestamps along this experiment. So we would have people, this guy would see it first, this guy would see it next, and then they would compare those timestamps to the altitude of the light at that time. So we would be able to see how light works, or at least the curving of the horizon works at extremely high altitudes, something that I think we just never delved into before.
Yeah, and just to
Mr. Sensible did it.
To be clear, on concave Earth, from Cuba you could see Maine.
Good.
If the Earth were concave.
Wait. No. That assumes that light travels straight.
I mean, that's not an assumption. Light does travel straight.
Yeah, unless acted upon by something to make it.
And I can prove that it
So,
doesn't.
okay.
I mean, the LIGO installations show that it does. They're not. They literally the LIGO installations have literally just managed to show the distance to merging neutron stars and help us understand the expansion of the universe. I don't say that's a waste of money.
Well, it's a misguided interpretation. If I had a few $1,000s for a balloon and a couple buddies and some telescopes, then I could prove that we need equipment wasting billions of dollars on this giant interferometer because I just have a little one on its side that shows that we're wasting our time.
Do you not think that a giant one might be slightly more accurate than a little one?
Looking for ripples in the space-time fabric when there is no space-time fabric, then yes, I think it's a waste of time.
But
wait, no space-time, but they experimentally verified space-time.
Well, based off of their determination off of experimental results. If you test something on Earth and then you try to verify it on Earth, of course it's going to work.
Well, no, that's not how science works. They've had an observation, they made a hypothesis, made a prediction, then designed an experiment to test that prediction, and the experiment validated their prediction from the hypothesis. That's it. That's all that happened.
Right, but it's still a hypothesis or theory. Now, my theory is going to...
Wait, hold on. You can't just say it's still a hypothesis. That's not how it works. They verified their hypothesis using experimental methods.
Right. And shedding light in a new direction that hasn't been studied yet will unverify that information and will continue the scientific process with a more refined understanding. You're asking me to halt my quest.
No, but you're like trying to read.
Already figured something out that was.
We've already. It's like if we said to everyone, 1 + 1 is 2, and someone went, well, actually, that might be true, but I'm going to retest it and do other things because I think if we interpret it differently, that could be something else. 1 + 1 is never going to stop being 2.
Nobody is denying that.
Okay,
I'm not denying that the effect of gravity,
and in the same way, the experimental evidence for the warping of space-time, affecting the path of light, is never going to stop being experimental evidence.
How about this? You made a wager for me earlier over the messages that told me that you would wage your channel if I could prove you wrong. If I get the funding to do this, I will prove you make your predictions about what the altitude of light will be at every single degree from 0 to 90, and I will do the actual experiment and prove that it is predictably wrong and mine is verifiably correct. And that is where I will end that discussion.
Okay, I mean, so you would base it on...
I would say you'd need to get that through peer review.
Yeah, I mean, if you could verify that the angles are incorrect, I mean, frankly, just an EQ mount disproves what you're saying here.
What?
An equatorial telescope mount kind of disproves your whole thing here, but
he's claiming that light doesn't travel as it's been confirmed to travel. So an EQ mount, I guess, can have whatever.
Oh yeah, still just receiving light, isn't it?
Explanation he wants to put in, I guess. So here's the thing I really want to get to, Doug. There is a 9.8 meters per second squared downward acceleration. That's undeniable. It varies all over the Earth, but not by a lot. What is the hypothesis that can output that magnitude in your model?
The hypothesis depends on 3 parts. One is the centrifugal force, that we know the radius remains constant at most points in the Earth, and we know that the rotational velocity is determinable based off of the geometry of a sphere. The second part is the attraction to the center. We have to figure out what the constant is for that attraction in order to start verifying it. So that takes a lot of experiments at a lot of different altitudes. The third part is the spring, which is negligible except for its conceptual effect on the shape of the atom. So with those 3 in consideration, we'll have to take what we know, which are verifiable, like the force of gravity, and we'll have to fix that to figure out what the other variables are. And I've done that in one part of my book, but I only have limited information to build off of. So that's why it is so essential that we continue this quest to find more data to build this theory more complete.
Okay, so you don't have...
Well, I'm not a programmer, and I don't have the experimental results to work with. I need to continue spending money on experiments to find those numbers so that we can build a functioning programmable model. This is a very thin book.
So all right. So you think we live in the inside of the sphere, and a sphere is rotating. The main cause of the downward acceleration is centrifugal force. The main. Okay. And you realize, and I know you said this to me before, that at the equator, if it's primarily caused by centrifugal force, then at the equator the force would be significantly higher than at 60 degrees north, and at the North Pole, South Pole, it would be, not existent based on centrifugal force. It would be completely based on. If the
poles were not tilted and rotating around through the cosmos. See, the Earth rotates on its axis, which could account for some centrifugal force. However, it would have to be such a minimal.
Is this just your conjecture that the Earth?
This is as far as I can get the explanation at the poles versus the equator. At the equator, there is a significantly more amount of centrifugal force, which means there must be more attraction to the center. It must be considerable enough to counteract that, to maintain the 9.8. Now, the reason I think it's a homogeneous almost everywhere around the Earth is because that was a settling number. The Earth bulges out on the edges. It also has a more donut-shaped galaxy around the center. So the electrons at the center reach closer to the protons around the equator, whereas there's a lack of electrons reaching out to the poles, so there's a lack of counterbalance. And that's why we eventually get that consistent 9.8 everywhere on the surface within the sphere. That's going to take a lot of math, and I'm going to have to spend a lot more time on that one. But conceptually, that's how I see it working out.
All right.
But again, it's not equal though. How does your model explain the fact that the gravitational acceleration isn't equal?
It would have to be a constant trade-off between the variables so that it did come out to be equal, because we know it is equal.
But it's not. That's what I'm saying. So it's not equal. The gravitational acceleration around the Earth is not the same.
Okay, I understand that.
It sounds to me a little bit like you picked a conclusion and now you're trying to find stuff to support.
That's how I described this journey at the beginning.
All right. Well, all right. We've got some super chats that people are asking about. If you don't mind,
happy to.
Yeah, you want to stop sharing and then we can put.
Sorry.
Yeah. I can stay for another 10 minutes, dude. Then I need to go to bed.
All right. He's gonna get in trouble if he stays up too late. People.
All right.
Mine Duck for $5. I had 2 streams going for a while. Sorry, I didn't stop the previous one. He says it's not very nice. He says, I'm no genius, but I think this one's got brain worms from something with the neighbor's dog. So sorry, I didn't read it.
Hey, if he's got the imagination for it, I don't blame him.
All right, let's see. Oh my goodness, there's a bunch. Yeah, people liked your picture of the butt. Nuclear fission. Harold, let's see. Do you have you have to appreciate how much effort it took to make all this stuff up, although that effort would be better applied to just learning things. And I have to agree, Doug, if you didn't disagree and argue with your teachers and just learned the stuff, I think you could have skipped a few things.
Well, the benefit from this was I was able to come up with the right answers with my own model. I just simply had to flip it inside out and then flip it back the right way to explain things that happened. But I was using this as a tool to
but your model isn't yet predictive, right? It's just kind of vague descriptions. It needs to be predictive, like numerically predictive. Numbers.
Like if I said to you, can you explain to me and tell me when the next time Halley's Comet will come back into the solar system is using your model? Could you do that?
I would have to spend more time on actual computer input.
Right.
But yes,
why is there 2 times in the year that we pass through the trail of Halley's Comet and have the Perseid and the acid meteor showers? Why does that's predicted with our model? What's the explanation for that on your model?
What we just apply the vectors of gravity used in the beginning, and we just flip the models inside out, compare the data, and then adjust it accordingly.
Well, but there's an explanation for it. The Earth is literally going through the trail left by Halley's Comet, right? That's why there's the meteor showers. So why is there the meteor showers at all on your model?
Meteor showers are a path on their own, moving within the cosmos, and their data is equivalent to the data that we collect. It was just inverted. So I would have to, I did not spend the time to make those equations when I was making this book. Like I said, it's a very primitive version of this model. but it is capable of predicting those things.
I don't think it is. I 100% disagree with you on the assumption there that it could predict those things. It's not. No. I'm straight up saying that what you're explaining has zero predictive capabilities.
And I'm saying that you misunderstand it because it clearly does. It's clear to me because I understand it.
But I'm saying mathematically there is no predictive capabilities.
Not currently, but it has predictive capabilities, and that's
no, it doesn't.
Then what can it predict? What number can you predict? What specific phenomenon?
The radius of the Earth without considering the attraction to the center. I need to know what the constants of attraction are in order to actually predict things. But I'm telling you, conceptually, it will work.
Okay, all right.
And I'm willing to wait on it.
All right, let's.
I take that wager. All right, like 100%.
Then I need the funding to actually verify these things. I need the balloons, I need the telescopes, and I need the apps.
Of course,
weather balloons don't cost much, a couple $100.
I've never had more than $100 in my bank account.
Ooh.
I put every dollar into this thing. I put every free hour I had into working it and practicing my conversations. Like, I'm used to people not understanding it and getting offended and freaked out and very vulgar at times.
Yeah, no, we understand it, buddy. Honestly, it's just it doesn't work with reality.
It doesn't work with your reality because you haven't.
No, with the reality. I don't have a different reality to you. It doesn't work with the reality.
Okay, well, we're not going to agree. I have no intentions of changing your mind. I have intentions of the people out there listening to us determine who's right and wrong. And if somebody's out there with an open mind enough to actually consider this could work, maybe they could join me and make it happen.
But the thing is, right, that's something that I personally find offensive, right? Because I am open-minded. MC Toon is open-minded because science forces us to be open-minded. If new data comes along, a new way of working, a new model that is better at doing the things that the heliocentric model does, then that is what we would go, because we actually have an open mind. Whereas I don't think you have an open mind because you're unwilling to accept that you don't have a clue what you're talking about.
Boy, somebody's grumpy.
That was literally the opposite of what you just said.
I'm not going to convince you tonight. I know.
Craig, he called you grumpy. Oh my gosh.
Yeah.
All right. I got to read some more of these super chats here. There's some good questions. I really thought that you had kind of said you were going to have some numbers for gravity, but okay. All right.
I have numbers to indirectly support this concept. I don't have enough right now to make any claims of numerical value.
I mean, because if you could, and you could beat the existing gravity, you could get that $10,000 IOU from Flat Out Hero.
Yeah.
That he would never pay. All right, so let me see here. We got Mike Billars says, when you say it's just the first edition, do you really mean scribbles on the back of a cocktail napkin while being effing blitzed off vodka? Is it vodka, or what is your particular?
I can't drink. The medicine made me have ulcers, so I do not mess with alcohol.
Okay, so it's not vodka, Mike Billars.
It's isolation from culture, if that explains the personality disorders.
Were you social distancing before everybody had to?
I've only seen a handful of movies outside of my childhood, and I only listen to music I've known my whole life. So it's a bit of a psychological anomaly.
All right. Connell Silver first says, Doug, your model has no evidence or math. So I know you're like you need your army of grad students.
I've done what I can. That's as far as I've gone.
Maybe if you could focus in on one particular aspect that you think you could get some predictive capability to,
which is the light, which is the altitude of the horizon. That's exactly why I wanted to end on that one.
Okay. PG Tony, who works with gravity, says, in the butt picture, would it not always be the case that somewhere in the inside of the shell is experiencing a solar eclipse?
Yes, you can always hide behind the moon.
Always. But we don't see it. Even Sleazy Warrior didn't.
No, because if we go back, sorry, I want to actually answer that one.
Okay.
Let me pull up my screen share.
I didn't bring enough
There
face
is
protection.
an eclipse season. What I've showed most of this time so far has been two-dimensional cutaways. But in order to understand the three-dimensional path that light takes, we have to understand that the shadow of the moon is not always going to hit the Earth, because it requires the alignment of the sun and the moon perfectly, just like it does in the current model. And like I said, if you just flip those things inside out, you'll see that the plane that the moon creates and the sun creates have to line up in order for the shadow of the moon to reach the Earth. Otherwise, the moon will find itself closer to that curve that just goes back towards the center.
Okay. Okay. Michael Hoyce says, is he showing a Dyson sphere? It kind of is, isn't it?
Is that the one on the bottom of the vacuum cleaners?
No, a Dyson sphere is the idea that you take all the matter within a solar system and you build a sphere out of it, leaving the sun in the middle, and then you live on the inside of the sphere.
Yeah, interestingly, they actually think that it's much more likely they could create a Dyson swarm rather than a sphere.
Swarm.
Yeah, so lots of tiny little panels rather than one massive connected thing. It'd be a much better way of doing it, apparently.
I would go with Ringworld myself.
Yeah,
I like that.
Halo Infinite comes out quite soon.
Yes. All right.
I need an Xbox Series X.
PhD Tony doesn't believe in space, uses it to disprove G. That would be the fallacy of stolen concept, right?
Mm-hmm. Space definitely exists. It's above us. It's within us. And there's an infinite amount of it because as you get closer to the center, you shrink. So I'm just merely trying to...
Why?
Inside out. Because the speed of light changes and length and the...
Why?
Length in regards to light years is dependent on the speed of light. So if you reduce the speed of light, you reduce the length contraction, or you compress length by a ratio of the square root of the factor of the reduction.
Yeah, but why is it slowing down?
Because the springs are getting closer together.
Why?
It takes for light because the atomic model is inside out. The electrons are in the center. That's where the springs originate, and the protons are on the edge. That's where the springs expand to. As the springs get closer, since they transmit light, then they must transmit light at different speeds based off of the different distance between them. So as they, on average, get closer together, the speed of light on average will slow down.
All right. Mitch,
wow.
Michael Hoyes says, why do these guys always look in 2D? 3D destroys this.
3D requires a lot more math.
Yep, the math for 3D is harder, yes.
But
Mitch,
not...
hold on. So, Del, does any of this make sense to you?
No.
What else?
No. Sorry.
Mitch Jones says, message retracted. Thank you, Mitch.
My curiosity is piqued.
Yeah.
It was the kill code. Received, understood, activated in T-minus 400.
Excellent.
Is that a threat?
No.
We couldn't tell you, then we'd have to kill you.
These are not the droids you're looking for. D Mouser says, so if Earth encompasses the sun, why do we see stars? Where are the stars in your model?
The stars are in the center, but the light does not travel straight. It takes a almost opposite of straight approach. It goes in the opposite directions and then eventually gets to you from the left and the right side of your horizons. So even though the stars originate in the center, the light is taking a completely 180-degree curve to get to you first. And since your eyes interpret the angle, we assume that the light is originating in a straight line. It's the same description for mirages that appear in the ground on flat surfaces. It is the light going down then up naturally that makes the sky appear in the asphalt.
So my dealer's watching and he says, can he get some of what you're having? People would like it.
It's available. All I need is a prescription.
Oh, all right. Why is the outside of the concave sphere full of magma, and how do seismic waves work?
The outside of the sphere is full of the heaviest elements due to the centrifugal organization of it. So the heavier elements tend to be a lot hotter due to their radioactivity and then come across as magma.
What if they're not radioactive?
Wait,
like iron?
what now?
The deeper we go, the heavier the elements are. That's just...
But they're not radioactive.
If we got deep enough, we would find a layer of plutonium, most likely.
Most likely. Anything to support that assertion?
It's just conjecture. Probably Einsteinium is what's the final layer, right?
Whatever's the heaviest would be on the edge. That's
Einsteinium, certainly. Okay. Lyric Edge had a question earlier. Ask how electrical devices don't experience issues through these electromagnetic fluxes.
What flux?
I don't know.
Next question.
Okay. Let's see. Mike Billar says, sorry I missed the start of this presentation. How much glue did Doug drink?
Drink or huff? That's not how you get out.
Yeah, you don't drink glue prior to coming up with this. You sniff it, I think.
Right.
Yeah. I mean, yeah.
Not a lot.
Not a lot. Just the good. You start with the good stuff. Indie Tiger, a one-dimensional measurement is an impossibility.
Yes. In the current model, maybe. Who knows? I'm getting exhausted, to be honest.
Okay. All right. I'll try to get through this. Mitch Jones says, Doug got a buzz. Love Trevor, Jordan, and Mitch. Do you?
I got a buzz. This team, Doug got a buzz. That's my brother. That's an inside joke.
All right.
How much did they pay for that comment?
That was $2. Thank you very much.
Oh man, they should have done $3.50.
Asylum asks, why is all navigation based on the globe? But of course, navigation works on the inside of a sphere.
Yeah, it's the same on both cases. It's the surface that we're matching, and those don't change. It's still curved. It's still predictable. We're focusing on what happens above the Earth's surface, which is inside in my model.
All right. Stringer News 1 says, irony, when gravity dies from a slip and fall.
I can see that. It's pretty clever.
Yep. Andrew Stahl, and I think this is the wrong word, but he says his hubris is off the flipping charts.
What do you think the right word is?
I would say confidence.
Oh, well,
I do
agree.
appreciate the confidence. That's good. Somebody said arrogance, and I'm like in the chat, and like, yeah, I don't think that's right. You're not. I think confidence is the right word.
You're like proud of your ignorance. Is that what arrogance is? Because that might make sense. I could see how that would be a solid description of my personality.
All right. We got General E. Shady says 500,000 behind FDFE. I offer it to Flat Earth 2.
Flat Earth 2.
Yeah,
Oh yeah, because this is like a semi-flat model when given that definition.
Well, I debate flat earthers more than concave earthers. I mean, you're a rare breed.
I've heard that a lot.
There's not a lot. Yeah, there's a small number. So there you go. We got PhD Tony again. If we're on the inside of a sphere, which is spinning, doesn't centrifugal force act in the opposite sense to what is observed? And that's because at the equator, the downward acceleration is less than at the poles.
That would have to depend on the counterbalance from the attraction to the center. So that's where we need to go further with that experiment and find out what that number is to figure out what that attraction should be.
What is the mechanism?
Right. So the mechanism is that the stars are reaching out closer to the horizon, to the equator, and that's why the excessive centrifugal force is counterbalanced with a larger counterbalance to give it that same 9.8 in most places to a degree.
All right. Michael Hayes says, why are triangles on Earth all greater than 180 degrees?
Is that the take 3 90-degree angles and end up where you started flat Earth counter argument?
It is.
Yeah.
This is not a flat Earth. This is not the disc in space on the back of a turtle. This is a loop.
No, it's a sphere, which that only works on.
No, actually,
I'm saying my model is not a disc.
It works on the inside or outside of a sphere. Navigation is essentially the same. You can do 3 90-degree triangles or 90-degree angles on the inside of the sphere, just like on the outside. It doesn't change that part of it. That's the one thing the concavers have over the flat earthers. They have a map that works.
Well, it's a sphere.
All right, we agree on it's a sphere.
I'll go ahead and write that in the statements list. Everybody says true on that one.
All right. Let's see. We've got Rocky Bixby says the British Astronomical Association states that atmospheric refraction puts light on a straight line after leaving the atmosphere.
Right. So that's why I'm going back to this part where it all of a sudden curves away from the Earth to get back to its original trajectory, just misplaced. So if that's true, then there's no explanation as to why. There is an explanation as to why like sticks to the Earth's surface longer than it should, but there's no explanation as to why it corrects itself with like some kind of memory in a sense. That would only be explainable in my model.
Yeah, but again, that double curve only happens on your model. It doesn't.
Exactly. Well, it happens when taking the functionality of my model and then flipping it out to the perspective of the current model. That's when you'll see light acting in ways that would raise eyebrows. But when we flip it back inside out, you see it's one continuous curve that has a predictable trajectory going towards the center, if not intersected by the Earth's surface. Indeed.
All right, Toon, I'm going to have to drop out now because I'm struggling to stay awake.
Yes.
It's been a very interesting conversation, and please unblock me on Facebook, dude, because I'd like to carry on the conversation. I have many questions. Yeah, and let me just explain. I wasn't being rude or insulting you when I said that thing about that shows that I don't have a higher education. It's just when you said that to me, you said, oh, well, you're just repeating the words that you've heard before. That's how you got your degree. To me, that statement shows that somebody doesn't have higher education, because that's not what higher education is. It wasn't directly insulting you. It was a logical deduction based on what you said to me.
Right, but how can you make a logical deduction that says it's false when it's clearly true? I've been to school. That's what got me. But we're going to save this conversation later because it is personal. And this is.
But that's what I said. I was just trying to make out that I wasn't insulting you with that. I was just making a logical deduction from the thing that you said to me. Okay. Right. Anyway, Toon, thank you very much.
Thank you, and Craig, for coming on. Good to have you.
No worries. And anyone that came over from my channel, please make sure you subscribe to MC Toon. Otherwise, I will send Red Rhetoric to stare at you. And you don't want that. That's banned by the Geneva Convention. But see you later.
All right. Bye, Craig. Thank you. All right. Just a couple more here. We got Connell Surfer. Silverfur says, summary, all your arguments are pure conjecture.
Can we define the word conjecture before I respond?
I use what you want for.
I understand that this is a Swiss cheese styled model right now, but it is existing and it is capable of filling in those holes. So whatever doubt there is, I've heard it, and I'm certain that it will be eventually satisfied.
All right. Eric for $4.99. Great question. What happens if you dig through the shell and fall outside the universe?
You cannot dig through the shell unless you have material strong enough to dig through the heaviest parts of it. And if you were to somehow make it to the edge, you'd just be stuck to it, unless you were made entirely of neutrons, in which you fling out into the abyss.
All right. So yeah, make it out of Einsteinium, right?
Well, I'm sure there's a layer of it, but if there's anything heavier, there's another layer of that.
All right. If there's anything heavier, it is.
There's always a bigger fish.
It is metal. Metal is heavy. Good metal is. All right. So Hugh Jars, Hugh.
This is the second time you've asked me
from
this.
Earlier. Yeah.
Okay.
Hugh Jars. He says J.M. Truth's love child, perhaps. When called out, he just makes stuff up.
This is original thought, so this, I guess, would share the definition of making it up.
Absolutely. Connell Silverfur says, I'm no doctor, but I would diagnose Doug's delusion as being caused by a lack of protein from too much word salad in his diet. I prescribe a burger. Now, but he's no doctor, so take the burger on your own whatever.
I do have a very small palate when it comes to my word salads.
Yeah, it is a little more restrained than Austin Whitsit's word salad. So, and we already asked about triangles on Earth greater than 180 degrees, and then Stringer News 1 for $2 has no message. So I don't know if that was on.
Silence speaks volume.
Oh, here he says, why don't the heaviest elements just fly off?
Because they have protons in them and they're attracted to the center. And there's also the springs that are like leashes, which prevent them from flying off. That was covered in the tiny Big Bang animation.
There you go. I love this.
All right. Well, it's 11 o'clock on the dot. What do you say we call it a night?
Yeah, I think that's fine.
Or 10 for you, I suppose.
It's been interesting, Doug. I think you have some interesting ideas. I think, though, better that you could maybe get a better understanding of the current model.
I have a very good conceptual understanding of it, and I see it as a waste of time to find out the theories that go further than necessary, because I think we got it wrong at the beginning, and I'm the only one looking in the opposite direction.
Okay. So there you go. Anything else you'd like to say before we wrap it up here?
Oh man, if I did, I don't have the mental capability of searching for the words. I am tired.
All right. Well, I appreciate that you were on. I appreciate everybody here. Let's see. I'll get a couple the super chats. Oh, we got one more.
Take it.
And this is he says, if we're on the inside of a globe, how do we see a horizon and not more of Earth? I mean, if we look up, we should see.
Right. So the same concept that dictates the mirage, that nature of a mirage, is responsible for us seeing only sky above the horizon. If the light traveled straight, we'd be able to see the curve all the way around like we do in that Halo video game that Craig mentioned earlier. But we can only see the sky as blue and the ground as a foreground, but we get this glitch, this sliver of mirage that eventually happens when we're looking too level for too long of a surface. And if we focus more on that specifically, we'll find a lot more things that we've never looked before.
But why is the sky blue?
The sky is blue because the wavelengths are shorter than the sky when the sun is in the middle of the sky during noon, then the distance it must travel is short. So due to scattering and whatnot, the average color that gets to us is the blue. But when the sun travels 25% around the cosmos and the light has to go twice the distance, then that light must become twice the wavelength, which is why blue becomes red. And the blue and the green and the yellows in the sun no longer can reach us, so the sun goes from white to red. So there's a lot of easy to understand explanations that will just get you guys going in the right direction. The book doesn't cost anything if you wanted to go to the website and just skim through it, look at the diagrams, avoid reading the words because they're just there as placeholders. All of this is the pictures, and if it inspires you, if it makes you think a little bit differently about the sky above us, then maybe your thoughts can help bring this closer to completion.
So, all right, I put the link to your website where the book can be found in the description. Everybody in the chat, I have his YouTube channel is linked at the top of the chat. If you want to go give him a sub quick, just to help a brother out.
Followers, that would be incredibly appreciative.
So, all right, well. Thank you very much, Doug. Thank you to everybody that the super chats and channel members and patrons. I appreciate very much. I'm trying to get a video out this week soon. Don't know. I will not be doing an after show. We did a pre-show. If you missed that, go watch the pre-show again. And so with that, there we go. Thank you, everybody. We'll see you again next time.
Thanks, Tim.